Welcome to this explainer. Today, we're tracking the wild financial roller coaster of artificial intelligence. We are quite literally going to follow the money, tracking exactly how this technology evolved from its incredibly humble, cash-strapped beginnings all the way up to the modern mega deals dominated by corporate tech giants.
So let's dive right into this. How exactly did we go from a measly $7,500 grant to a multi-billion-dollar industry? You see, to really understand where AI is heading, you have to look at who's been holding the purse strings, what they were hoping to buy, and what happened when that funding suddenly dried up. The contrast between those microscopic early budgets and the massive corporate investments we see today is absolutely staggering.
Here is our roadmap for today. We'll start with the birth of AI, move into the first golden age, brave the first AI winter, examine the billion-dollar bubble, and finally arrive at the deep learning era. Part 1. The birth of AI and the summer of '56. Back in 1955, artificial intelligence was essentially just a highly ambitious summer project pitched to philanthropic foundations. A small group of researchers, including John McCarthy and Marvin Minsky, wrote a proposal to study artificial intelligence, a term they confidently just coined right there on the spot. And get this, they requested about $13,500 to host a summer workshop. Think about the sheer audacity of that. For the price of a used car today, they were planning to lay the groundwork for human-level machine intelligence. By 1957, this academic spark led Frank Rosenblatt to propose the Mark I perceptron. This early neural network hardware actually secured an initial $10,000 contract and later a $153,000 contract directly from the Office of Naval Research. $7,500. That's it. That incredibly meager figure is all the Rockefeller Foundation actually approved for that 1956 Dartmouth workshop that officially birthed the entire field of AI. They originally asked for roughly $14,000, and the foundation simply cut it in half. Early AI had to operate on these microscopic budgets out of pure necessity. It literally forced early engineers to adopt highly optimized shortcuts and clever theoretical frameworks simply because they didn't have the cash to buy serious computing power. I mean, every single calculation had to be painstakingly justified when your entire discipline's budget is less than a modern intern's summer salary. Moving on to Part 2, the first golden age, the era of ARPA's blank checks. Following those shoestring budgets, the Cold War triggered a major geopolitical panic, and suddenly the purse strings were thrown wide open. The U.S. military desperately needed strategic advantages, pushing AI funding from thousands of dollars into multi-million-dollar institutional contracts almost overnight. Take MIT's Project Mac, launched in 1963. They secured an initial $2.2 million grant from DARPA that ultimately scaled to over $4.3 million at its peak. Their goal wasn't just basic research anymore. They were trying to build foundational operating systems and resource-sharing computers. Over at Carnegie Mellon, the Speech Understanding Project secured an incredible $15 million in total DARPA funding just to figure out how to make computers comprehend spoken human language. The scale of investment completely transformed the field, from a scrappy academic pursuit into a massive defense initiative. And here is why this matters to you today. The everyday tech sitting in your pocket right now was directly bankrolled by these exact early military gambles. The A-star routing algorithm, originally funded during this era for autonomous robotic navigation, is the exact same underlying logic routing your Uber driver around a traffic jam today. And Lisp, the primary programming language born in this heavily funded era, went on to power CAD software and early internet platforms. It is genuinely amazing to realize that it took half a century for these massive 1960s defense investments to finally reach the everyday consumer's smartphone. Which brings us to Part 3, the first AI winter, and when credibility collapsed. Well, rampant overpromising eventually caught up with the researchers. By the 1970s, the complete failure to deliver on sky-high expectations led to frozen funding. So the crucial takeaway here is how a massive financial bet completely backfired. The U.S. government poured approximately $20 million, which was an absolute fortune in the 1960s, into computerized machine translation. They were hoping for a rapid, Cold War strategic tool to translate Russian documents. But the 1966 APAC report brutally revealed the truth. Unedited machine translation took twice as long to read as human translation, and it was completely unviable economically. It was a humiliating public failure. That $20 million bust single-handedly killed U.S. funding for computational linguistics for nearly 2 decades, sending the whole field into a deep freeze. And across the pond, things weren't looking any better. In 1973, the Lighthill Report completely shattered European confidence in AI. Commissioned by the Science Research Council, this report heavily criticized basic AI research for consistently failing to overcome real-world complexity. The researchers could solve simple, controlled toy problems, sure, but the algorithms completely collapsed when applied to messy, real-world data. The financial fallout of this critique was absolutely devastating. The British government slashed their funding, dismantling almost all basic AI research in the UK for a decade. The winter had well and truly arrived. Part 4. The billion-dollar bubble and the 1980s hardware race. Fast forward to the 1980s, and the optimism along with the money came roaring back, inflating a massive economic bubble. Just imagine dropping $100,000 in 1980s money, no less, on a single computer. Eager enterprises, often subsidized by Strategic Defense Initiative funds, were throwing down that exact amount for a single custom Lisp machine from companies like Symbolics. These were massive, dedicated workstations specifically optimized to run symbolic AI programming languages natively. The hype around expert systems was back in full swing, and organizations were happily paying astronomical premiums for this specialized hardware, totally convinced it was the only way to achieve artificial intelligence. This domestic spending spree quickly escalated into a global geopolitical arms race. Terrified of Japan's massive $320 million fifth-generation project, which aimed to create these epoch-making computers, the United States countered with DARPA's Strategic Computing Initiative. The U.S. budgeted over $1 billion, chasing science fiction-level goals like fully autonomous ground vehicles and automated battlefield management systems. Not wanting to be left behind, the UK jumped right back into the fray with the £350 million ALFI program. Superpowers were pouring billions into the race to dominate machine intelligence, absolutely convinced that victory belonged to whoever bought the biggest, most expensive hardware. But, as you might guess, this hardware bubble burst practically overnight in 1987. Why? Because standard $5,000 desktop PCs and Unix workstations suddenly became powerful enough to run Lisp software just as well as the specialized hardware. Imagine the sheer panic in the boardrooms of those specialized AI hardware vendors. Enterprise clients woke up one morning and immediately realized they didn't need a $100,000 behemoth when a $5,000 beige box delivered the exact same business outcomes. The hubris of these custom vendors was met with the brutal reality of consumer tech curves. This cost reality immediately bankrupted the specialized AI computer industry, collapsing the billion-dollar bubble and ushering in a severe second AI winter. Finally, Part 5, the deep learning era, defined by corporate mega acquisitions. This brings us out of that second winter and straight into the modern deep learning era. But notice a massive shift here. The primary funding source has transitioned entirely away from government defense agencies and squarely into the hands of corporate tech giants. By 2014, the scale of investment had become completely unrecognizable. Google paid an estimated $643 million to acquire the London-based startup DeepMind. Let that sink in for a second. We started this explainer with a heavily negotiated $7,500 grant from the Rockefeller Foundation. Now, a single tech company is dropping over $500 million just to acquire a promising talent pool and some algorithms. It shows just how astronomically the financial baseline of AI development has grown. And Google rapidly compounded this footprint. Soon after the DeepMind purchase, they scooped up 2 additional Oxford spin-offs, Dark Blue Labs and Vision Factory, for another $50 million. But the real financial story here isn't just the acquisition costs. It's the underlying infrastructure. By embedding DeepMind into Alphabet, the lab gained access to massive compute resources and corporate capital expenditures. Across the major tech giants today, AI infrastructure spending is projected to scale toward $175 billion by 2026. That is just a staggering figure. This completely dwarfs the combined military and state budgets of the 1960s and 1980s. What we're witnessing is the ultimate shift in power, moving the future of artificial intelligence away from sovereign governments and directly into the server farms of a few mega corporations. I want to leave you with this final thought today. We've seen how AI funding has wildly cycled between meager academic grants, multi-million-dollar defense contracts, billion-dollar sovereign initiatives, and now hundreds of billions in corporate tech expenditures. Given this incredible historical cycle of boom and bust, what do you think? Are the current billions building a permanent path to general intelligence? Or are we just pricing in the most expensive AI winter yet? Thanks for joining me on this explainer, and keep questioning the money.